Sometimes we get sort of locked into the idea that we have to read from left to right, like we do when we're reading a book, say. So if I have an identity, say, sine of alpha plus beta, and I know how that goes, that's sine, cosine, for the sine, the sine, oh, that's confusing. For the sine, the signs are same. For the sine SIN, the signs SIGNs are the same. And then cosine, sine. So there's an identity for the sign of a sum, and sometimes we feel like, okay, that means if I have something that looks like what's on the left, then I can change it into something that looks like what's on the right. But here's the thing, equal means equal. Equal signs work both directions, they're true both ways. So if I have something that looks like what's on the right, I can change it into something that looks like what's on the left. Such as this example right here follows the pattern for the sign of a sum, what's on the right-hand side. We got sine, cosine, cosine, sine, and the angles are switching. Yep, that's what we got. Sine, cosine, cosine, sine, and the angles are switching. So in our scenario here, the role of alpha is being played by pi over 5, and the role of beta is being played by 7 pi over 10, and I can rewrite this entire thing as the sine of the sum, alpha, plus beta. Well, that looks more simplified. Don't stop there. We can do better. We can, these are just numbers. We can actually add them together. Common denominator, same as we always need for adding fractions. If you need to come off to the side and think about that, that's totally fine. Pi over 5 plus 7 pi over 10. I'm going to need a common denominator. It's going to be 10 since 5 divides into 10. So I can multiply top and bottom by 2. So I got 2 pi over 10 and 7 pi over 10. Last I checked, 2 plus 7 was 9. So that means we have the sine of 9 pi over 10. And that is much more simplified than it was at the beginning. Notice that's not an exact value, but that wasn't the question. The question wasn't find an exact value. The question was simplify, and one sine of one angle is much more simplified than the thing that we started out with. Got one more here. You might notice this expression is following the pattern for a tangent of a sum or difference, and in particular for a tangent, we can look at the sine SIGN of the numerator. That's a plus, so this is tangent of a sum. Tangent of, well, I got 5x plus, my other angle is 2x. There we go, don't stop there, add them together. Tangent of 7x. That's much more simplified than the expression we started with. It's not an exact value, but I didn't want one. I just wanted it simplified, and there it is.